We talked about kinematic equations and different quantities which are related, we had a relation. Today we'll apply those concepts to a problem. Let's take a question and try to understand. Suppose, so the question goes like this. Suppose the radius vector R is given by AT1 minus alpha t, where A is a constant vector. So a constant vector means that it doesn't change with the magnitude of it does not change and the direction also does not change, it remains constant. That is what constant vector means. So in this equation, A is given as a constant vector and alpha is a positive constant. Is any positive factor, suppose. So what we need to find, given this situation, we need to find first the velocity and acceleration let's take another symbol, let's take W, acceleration W, as a function of time. Well, the second part of the question says, find the time interval delta t if it returns to its initial position. And then we need to find the distance s during the time interval delta t. Well, so let's understand the question first. It says that there is a position vector, radius vector given r as a function of time, and it is at times 1 minus alpha t, where a is a constant vector, which means it doesn't change in terms of magnitude as well as direction, and alpha there in the equation is any positive factor. Well, so we need to find velocity, and we know that this velocity, if you differentiate that position vector with respect to time, you get velocity. So essentially it means if you differentiate dr over dt, so replacing this, which means that it comes out to be dat 1 minus alpha t and dt. Well, this is the function, and when we differentiate, it comes out to be dat over dt minus d alpha t over dt. Well, so this becomes a, and this becomes it is minus alpha t, so simply it becomes minus alpha. So it becomes minus alpha. T square, if you open this bracket, it's going to be t square, so it's going to be 2, because it at and alpha t square, so it becomes at minus alpha t square. Well, so it is a minus, when you differentiate t square, it becomes minus 2 alpha t. So which comes out to be, therefore, which comes out to be V, it comes out to be A if you take common in vector notations. So here also A is there, A time, because A is out of the bracket. So when we open the bracket, it goes there. So AT, and it becomes minus A alpha T square. So if you differentiate here, A alpha T square, it comes out to be minus 2A alpha T. And if you take the A outside the bracket, it comes out to be 1 minus, if you take A, it comes out to be 2 alpha T. So as a function of time in vector notation, we got this velocity. So this is first part of the question, and we got the velocity as A bracket 1 minus 2 alpha T. As simple as that. Then it says find the acceleration. So we just need to differentiate again. Therefore, acceleration W is dV by dt, and it comes out to be, if you differentiate this, it comes out to be dA over dt minus d2 alpha t over dt. So this goes 0. Differentiating any constant, it becomes 0, and this comes out to be, so 2 alpha if you take out, it's going to be minus 2 alpha, and this becomes just A is also here. So when you open the bracket, A also comes. So therefore we get acceleration comes out to be minus 2, A comes here, so 2A alpha. 2A alpha. So if you differentiate this, it becomes 2A alpha. This is what we get as acceleration. So two parts we have got, velocity and acceleration, as we move with the equations. And then in the last it says here, the second part of the question says, the time you need to find the time interval delta t if it returns to its initial position. So take note until here, and then we'll proceed further. So take note until this point, and then we'll come on to the second part of the question, which we want to find now here, the time interval and if it returns to initial position. Now there's one interesting point that you need to understand here. The acceleration is going to be negative here, right? That essentially means the velocity vector is directed in the direction. Suppose we take this radius vector, so it's going in this way, and the acceleration is directed in the opposite direction, which means that it's going to go somewhere here to a point, and it's going to then return to the point. And that is what it says in the second part of the question, the time interval delta t that we need to find if it returns to its initial position. That is, this negative acceleration would cause it to return to the initial position. So just keep that in mind, and then we'll move on to understand how we get this delta t with the notations that we have taken. Well, so let me rub this part of it. In the second part of the question, it says that we need to find what is the time interval delta t. So according to question, we can write here, according to question, at time t is equal to 0, we get r is equal to 0, right? So it returns when t is what the initial situation was, when t is becoming 0, r is becoming 0, and it returns to this point, initial point. So this is the initial point. When it returns to initial point, what is the time lapse? And that is what in the question it says it is delta t. So therefore, at time t is equal to delta t, at time t is equal to delta t, it returns to the initial point, and that initial position is r is equal to 0. So from the relation, we have r is equal to a t 1 minus alpha t. All right, so it returns to initial position, so we'll make this r0. If you make this r0, we get, so this implies that from here we get, if you put delta time delta t, so it becomes a delta t times 1 minus alpha delta t. Therefore 0 is equal to a delta t is equal to minus a alpha delta t. Well, so if you bring this into, if you just make the subject of the equation, we want this delta t here. So if you want to bring it there, that side, so it becomes therefore a alpha delta t is equal to a times delta t. So we get a cancelled out, and we get here delta t squared, right? So it is delta t and delta t, it's delta t squared, so it's going to be delta t squared. Well, so one delta t gets cancelled, and therefore delta t becomes 1 over alpha. So delta t becomes 1 over alpha. So when you open the bracket here, it becomes at minus at alpha delta t squared, right? So at time t is equal to, at time you can write here, at time t is equal to delta t. So we just substitute t with delta t, we get a delta t minus a alpha delta t squared, and then we get here alpha delta t is equal to delta t, and then one would get cancelled, delta t becomes is equal to 1 over alpha. So this comes out to be delta t is equal to 1 over alpha. Well, having understood this, now you can take down the steps. Then we'll move on to the next situation and the next point. So the next part of the question, it says that what is the distance s during this delta t? So we got this delta t is equal to 1 over alpha, and this is returning back. If it is returning back, then what is the total distance traversed, right? That is what we want. So third question says that you need to find s, right, during delta t, and we know delta t is going to be 1 over alpha. Okay, now look carefully. If a body goes in this direction and it returns back here like this, from this point, and we know that this total, this is t1 and this is t2, right? So this is t1 and this is t2, if this is the returning point. Suppose from O it goes to A, and from A it comes back to this position, and the total time is delta t. So the velocity here is directed in this direction, and the velocity here is going to be in the opposite direction. So suppose you take this as a x-axis, so if you can multiply the magnitude of v I cap, then this would be equal to v minus I cap while returning, and we have this v in the equation, right? So we know that s is equal to v dt. So from where did we get this? If you differentiate s with respect to, suppose we differentiate this, suppose we differentiate ds over dt, we get v, right? So therefore we get s or ds is equal to v dt. Now if you integrate both sides, you'll get what is the distance. Over time, as a function of time, we do have this velocity as a function of time. So if you remember the velocity as a function of time we got, here if you are going to differentiate, we got v is equal to dr over dt. Okay, so we got this as a, and this becomes, if you open the bracket, it becomes at, and if you differentiate with respect to time, it would just be a vector minus, here it would be a t alpha t square, so it's going to be d a alpha t square over dt, right? So if you differentiate this, it comes out to be a minus, so this a and alpha would be outside, and it becomes 2a alpha, right? And there's also a t there that would remain, so 2at, and if you take a common, so this comes out to be a 1 minus 2 alpha t. So we got this velocity, if you remember previously, we got this velocity as a function of time in this way, and this velocity, if you look carefully, it's going to return now, and we are taking into account the complete time duration. So half of the journey, and it is quite proportional, right? It's a symmetrical journey. So if it is going this way and returning the other way, the velocity, the magnitude is going to be negative, right? As per the sign convention, it's going to be minus I cap on its return. So if we want to write it for this time interval that we got, for half of the time it is positive, for half of the time it is negative. So we can write this v, right? So this is magnitude of this velocity, and this magnitude of the velocity is equal to this, which is a, if you just take into account the magnitude, it become a 1 minus 2 alpha t. So for when the time t, now we got this delta time as 1 over alpha, which means that if this time t is less than or equal to 1 over alpha divided by 2, so half of the time, for half of the time, right, it is a 1 minus 2 alpha t. But for another half, when this t becomes more than this half of the t, so half of the time that it has taken in total, so it becomes a, and this becomes negative, which means that it's going to be, if you take minus of it common, it will just come 2 alpha t minus 1, right? And this will be t for greater than 1 over 2 alpha. So if you take half of the time, it comes out to be 1 by 2 alpha. For half of the time, right, for half of the delta t, this is, the velocity is positive. For half of the time it is negative, we have seen here. So we get this v in two different functions we do have. It's just that this negative would change this, it would become 2 alpha t minus 1. Well, having known this, why we want this? Because in this equation, we'll be using this when we integrate this over 0 to delta t. So when we integrate this from 0 to delta t, we just need to put in that value here and perform the integration. So take note of these steps and then we'll move forward. Well, so now we'll continue from here. So therefore, this ds that we need to integrate 0 to s, so this is going to be v dt, right? And we know v, we have the values there. So if you integrate this from 0 to delta time t, and we have v dt. Well, now this is divided into 2 so that we have different functions there. So this actually shows that it is from 0 to half of the time, that is when this is 1 by 2 alpha. So this is 1 by 2 alpha. We have the function which is the top one, which is 1 minus 2 alpha t dt. So the v is this and everything remains same. Plus we need to then, because this equals what, half, and then it comes out to be this to the final time, that is going to be 1 over alpha. That delta t is 1 over alpha. This delta t is 1 over alpha. So we need to reach there. So the limit here is going to be 1 over 2 alpha. So from 1 over 2 alpha to 1 over alpha. This function would be a 2 alpha t minus 1 dt. So that is how we need to evaluate these two definite integrals to get the values. Well, take down these steps. It's quite conceptual, interesting to move forward, and let's integrate this to get the final expression. Well, so let me rub the upper portion and then we'll continue to integrate it. So I would write it here again. So we get as, when we integrate this, so it's going to be 1 over alpha, and we have the function as a 1 minus 2 alpha t dt. Plus from 1 by, so it is, let's take the half one, 1 over 2 alpha to 1 over alpha. And for this we have 2 alpha t minus 1 dt. This is what we need to integrate. Well, so if you open the bracket, it comes out to be, if you open the bracket, it comes out to be a, and for 1 by 2 alpha t, so this implies this is equal to a minus 2a alpha t dt, plus then we have to integrate from 1 over 2 alpha to 1 over alpha, and this is a 2a alpha t minus a dt. All right, so let's perform the integration. So this comes out to be a, so if you integrate this, it becomes a dt. So let's write it, no problem. It's 0 to 1 over 2 alpha, so it becomes a dt minus So now we are going to integrate this, it becomes t. So this definite integral, so this is going to be, it's going to be simply t, so we'll put in here 1 over 2 alpha minus 0, so it becomes 1 over 2 alpha, and here, so 2a alpha, these are all 2a alpha t is also there, 2a alpha t. So everything goes out of the integral sign. The only thing that is t here, that will become t square by 2. So it's going to be 2a alpha t square by 2. So we'll put that 2 out in the denominator, and here it's going to be in the bracket, it comes out to be t square. So this is square, which is minus this, so it comes out to be 1 by 4 alpha squared. This is what we get here. Well, now we need to add plus, and here same. So this minus this, so 2a alpha constant, we'll pull it out. T would become t square by 2, similar to this one. So t square by 2, the 2 will pull out, and then it comes out to be 2a alpha by 2, and then it becomes t square. So which means that this will be 1 by alpha squared minus 1 by 4 alpha squared. This would come here like this, and then minus, right? It's now this a is constant, we'll pull it out, and this again it would become t, so which means that this would be minus 1 over alpha. Well, and this will be minus of this, so minus 1 by 2 alpha. So minus and minus would become plus, so it will be 1 by 2 alpha. This is what we get upon performing the integration and putting the limits as we do in definite integration. So from here, what do we get? So let us simplify this a bit. So this 2 gets cancelled, this 2 cancels out. Well, so now we are getting this as 1 over 2 alpha minus this alpha, and this goes, well, so it becomes just a. Now a is always there, right? A is also here, and a is also here, so a always remains. So here also we have a. We should not forget a. A is here. Here also we get a in the numerator, and in the denominator we get 4 alpha squared plus, then we come here, it becomes a alpha. So if you open the bracket, it multiplies with this and then multiplies with this. When it multiplies with this, alpha and alpha gets cancelled, a remains, so it becomes a divided by alpha minus, when you multiply this, it becomes alpha and alpha squared will get cancelled, and a would remain, and in the denominator it would be a by 4 alpha, and then it comes out to be minus 1 by alpha plus 1 by 2 alpha. This is what we get upon simplifying this, and let's see something gets cancelled out. Yeah, well, so let's see what gets cancelled out. So we should not forget that here one alpha gets cancelled, so this alpha goes here square, so a by alpha and a by 4 alpha, and here it becomes a also, so it is a here, and here also we have a here, so a is always there. Well, so this is actually a here, and we get minus a by alpha, and here plus a by alpha, so this gets cancelled. This gets cancelled. Then we have a by 2 alpha. Here it is a by 2 alpha, and here also we have a by 2 alpha. So this a by 2 alpha and a by 2 alpha, so it becomes a by alpha. Okay, now here it is a by 4 alpha, and here we have, well, minus and minus. So this is becoming here minus, and we get here this minus this. Okay, yeah, fine. So this becomes a by 4 alpha minus a by 4 alpha. It becomes 2a by 4 alpha, which is a by 2 alpha. So one would get cancelled. So this, right, and this would become minus minus a by 2 alpha, and this is a by 2 alpha, so this gets cancelled, and we are left with this last one, which is a by 2 alpha. So that is what is becoming S. So which implies that this comes out to be, as a conclusion, so I'm writing it here, as a conclusion we get S, therefore we get S is equal to a by 2 alpha. This is what we get in the last, which is coming, everything else gets cancelled out. So we are remaining with these terms as S is equal to, which is the total distance, S is equal to a by 2 alpha. This is the answer for the third part of the question. So it's quite interesting to go step by step. It checks the concepts. It also checks how we apply the mathematical tool to get the answer. So take down these steps, it's extremely important. We'll move on further and we'll take up more questions. So watch the next video. Thank you.